Hello, my name is Philip. Hi, welcome to chemistry class note. So today we're going to be looking at calculations involving Lussacs law of combining volumes. First of all, Lussacs law states that when gases react, they do so in volume which bear a simple ratio to one another and to the volume of the gases and to the volume of the product if gaseous provided that temperature and pressure remains constant. So in this kind of calculations, the equation given must be balanced before we start to calculate. Once your equation is not balanced, then your answer will be wrong. Some questions, they will give you the equation balanced. Some, they will give you the equation, they expect you to balance it. While others, they won't give you the equation. That means you have to write your equation yourself, balance it before you start to solve. But in this case, the equation is given to us and it's balanced. So they are saying that calculate the combustion of carbon dioxide in oxygen can be represented by equation this 2CO plus O2 plus to give carbon dioxide. Calculate the volume of the resulting mixture at the end of the reaction if 50 cm3 of carbon dioxide was exploded in 100 cm3 of oxygen. Another language for this part resulting mixture is residual gas. Most questions they use the word the volume of the residual gas. That's what will be used. But yeah, they are using resulting mixture. Resulting mixture or residual gas is the volume of the product plus the volume of the unreacted reactant. You get it? The volume of the product plus the volume of the unreacted reactant or the reactant that was in the excess. If you add those two together, you get your residual gas or resulting mixture. So let's do this one. I'll first of all write out the equation again. This 2CO. Remember, they are all gas. They are all gases. Lussacs law. Liquid and solids do not enter into the Lussacs law. It doesn't operate under liquid or solids. Take notes. Alright, so I'm going to write 50 cm3 of carbon dioxide. I put 50 here. Then 100 cm3 of oxygen. 100. So the way to go about it, since we are given 50 here, look at the ratio. This is like saying ratio 2, ratio 1, ratio 2. Normally, we don't normally write 1. We know that there's 1 in front of oxygen. But we don't write 1. But take note, the ratio is 2, ratio 1, ratio 2. So, since we have 50, I'll start like this. Since we have 50, 1 over 2 of 50 is what I'll put here. It's like saying this 1 over 2 of 50. If I have 3 here, 1 over 3 of 50. If there's 3 here and there's 2 here, 2 over 3 of 50. Most of the equation, they always follow this pattern. 2 ratio 1 ratio 2. So I'm going to start with this. 1 over 2 of 50 is 25. I'll put 25 here. 2 times 25 is still 50. Since the ratio between here and this product is 2, automatically the volume of this product will be 50 because the molar ratio between this reactant here and this product are the same. That means the volume of this one will also be the volume of the product. So from here, I'm going to subtract. This is already gone. That means everything here was used up. Then here, 25 minus 100, I'm going to get 75. Then here we are left with 50. So they say the volume of the resulting mixture. The volume of the resulting mixture will be 75 plus 50. That means you get 125 cm cube. This is your final answer. In this equation, 50, 50, since everything was used up, this reactant is the remitting gas because everything was used up. While in this oxygen now, only 25 was used up, so this 25 was in excess. So this is the limiting gas, while this one is the one that is in excess, just in case. There are some questions that if whatever you have here is greater than what is here, that means you don't have to put it there. You have to bring this value down. Our third question is like that. You see what I'm trying to say. So let's go to the next question. This question now, what volume of oxygen will remain after reacting 80 cm cube of hydrogen gas with 20 cm cube of oxygen gas? So in this case now, we're looking for the volume of the oxygen that will remain. If you take note, in this equation, we're not given the equation. That means you have to write the equation and balance it. So it's between hydrogen and oxygen. Hydrogen gas and oxygen. Give steam. They are all gases. So I'm going to put 2 here. If I put 2 here, it will be balanced. Balanced equation meaning that whatever you have here must be equal to what you have here. So hydrogen here is 4. 2 times 2 is 4. 2 times 2 is also 4. Oxygen here is 2. Oxygen here is also 2. This 2 is affecting this and this. But this 2 is only affecting this one. So that's why oxygen here is 2 and it's 2 here. So the equation is balanced. As usual, it's still ratio 2, ratio 1, ratio 2. So the volume of oxygen that will remain after reacting 8 cm cube of hydrogen. So I'm going to write 8 under hydrogen, then 20 under oxygen. As usual, half of 8, I can put it here because half of 8 is 4. So 4 is less than 20. I'll put the 4 here. But if the 4 was more than this value that is here, what I need to do is I'll bring this same value down. But in this case, 4 is greater than 20. So I'll put 4 here. Remember, half of what is here, I will put here. Then 2 times 4, 8. So this one goes 20 minus 4, I'm getting 16. Remember, ratio 2 and ratio 2, that means automatically the volume of the product, which is steam here, will also be 8. But your question says, what volume of oxygen will remain? So your answer is 16. 20 minus 4, 16. What volume of oxygen will remain? This is the one that remained, or the one that was in excess. If they are said, which gas is in excess? Which of the reactants is in excess? Your answer would have been oxygen. Why? Because 16 remains. Unlike this one, everything was used up. This type that was used up is the limiting gas. Why this one? The one that is in excess. Because of this, it was 4 that was used up. Of 20, 4 was used up. We are left with 16. If they said calculate what is the residual gas, that means I will say 16 plus 8 will be the volume of the residual gas. But in this question, they just said we should calculate the volume of oxygen that will remain. So your answer is 16. Question above, what volume of hydrogen would be left over when 300 cm cube of oxygen and 100 cm cube of hydrogen are exploded in a sealed tube? By giving the equation, I'll still put it down here, 2H2 plus O2 to give 2H2O. So we're looking for the volume of hydrogen that will be left over. So 300 cm of oxygen, okay, 300 of oxygen, 1000 of hydrogen. All right, the usual 2:1. So remember I said if the volume here is more than this one, that means I'll just bring this one down. So it's the case for this one. Half 1/2, which is half of 500, half of 1000 is 500, but 500 is more than 300, so I cannot use 500. Just like saying somebody has 2 naira, I say you should give me 3 naira. I don't have up to you don't have up to 3 naira, so you can't give me 3 naira because you have only 2 naira. So it's not possible. So half of 1000 is 500. Because 500 is more than this one, I'm not going to use 500. Instead, I'll bring the same value that is here. I'll put it down here. Then 2 times 300, 600. Then, because of this, the molar ratio here is 2:2. That means automatically the volume of the product here will also be 600. So here, this is 0. Everything was used up. So 600, remove 1000 from 600. 1000 minus 600, you get 400. So your question was, what volume of hydrogen will be left over? So the volume of hydrogen that will be left over is 400. As usual, if they are said, what is the volume of the residual gas? I want to add this product plus this one. But since you are not asked for that one, so this is your final. Look at this next question. Hydrogen is between hydrogen and oxygen. So 50 cm of hydrogen are sparked with. So this 50 sparked with 20 of oxygen at 100 degrees and 1 atmosphere. The total volume of the residual gas. So here they ask us to calculate residual gas. As usual, half of 50 is 25. But because what I have here, but because 25 is more than what I have here, so I can't put 25 here. So I'm going to put this value down. If maybe what I have here is less than this, then I can leave it. But if it's more, then I'm going to use the same value that is here. I'll bring it here. Then 2 times 20, 40. Then because the molar ratio here and here is the same, automatically the volume of the product will also be 40. Because the molar ratio has to follow this 2:1:2. This are in ratio 2:1:2, 2:1:2. That's molar ratio. So from here, of course, this goes, everything was used up. 50 minus 40, so 10 was remaining. Here is 40, the volume of the product. So the residual gas, the volume of the product plus the volume of the unreacted gas, or the unused or unreacted gas. So it's 40 plus 10. That will be 50 C. Alright, for this question. 100 cm of CO is packed with 100 cm of air containing 1% of oxygen. If all the volumes are measured at SCP, the volume of the resulting gas would be, then remember figure 2, so the reactant was in SS. Okay, the first thing, write the equation So this question can be a little bit tricky. So we know the 10 cm cube of CO is mixed and packed with 100 cm cube of air containing 21% of oxygen. So they give you 100 cm cube of air. They didn't give you 100 cm cube of oxygen. They gave you 100 cm cube of air. So in this 100 cm cube of air, only 21% that is oxygen. And that's what we need so that we can calculate this question. So the first thing we have to get the volume of oxygen that is in air. This is like saying 21 over 100. That's percentage. 21% is 21 over 100 times 100. And then you are left with 21 cm cube of oxygen. So in this place now, it will now be 21 cm. Because of this 21%, I just say 21 over 100 times 100 over 1. In this air, you know air is a mixture of gases. There's nitrogen, there's oxygen, there's carbon dioxide, there's other inert gases. But we're interested in the oxygen. So 21% of oxygen in the air, that is 21 over 100 times 100. That is, you're getting 21 cm cube. So now here is 10 cm, and this 10, here will be 21. Half of 10, as usual, 1 over 2 of 10, that is half of 10 is 5. I can put 5 here because the value is less than this one, so I can put 5 here. But if it's more than this one, you have to bring this value down. 2 times 5, 10. Of course, this 10 minus 10 is 0. Then 21 minus 5, that is 16. That is 16. Then here will also be 10 because of the molar ratio between here and here are the same. So it will also be 10. So here, so okay, I said the volume of the resulting gas would be, resulting gas is the same thing as residual gas. So the resulting gas, like I said, the volume of the product plus the volume of the unreacted, remember, unreacted gases. Well, in this case, if you see the volume of, if you say is 10 plus 16, your answer will be wrong. Unlike if it's the previous question, yes, it's correct. But in this question, it's wrong because part of the unreacted gas is, 21% in the air that reacted, that is oxygen, that is 21 cm cube. The remaining one is still unreacted, which is 79. The remaining 79 did not react. You understand? Of the 100 cm cube, 21% is air, is oxygen, which is what we used. The remaining 79 did not react. So in calculating the resulting gas or residual gas, we have to add that value to these two. Otherwise, your answer would be wrong. So the residual gas or the resulting gas is the volume of the product, which is 10, plus the unreacted gas, or the one that is in excess, which is 16, then plus the remaining quantity, the remaining gas in the air that did not react, 21% that is oxygen. The remaining 79%, which is approximately 79 cm. So the reacting gas would be 10 plus 16 plus 79. That should be 105 cm cube. Don't forget how we get 79. Because 21% is oxygen, the remaining 79 did not react. We only used 21 cm cube. The remaining 79, we have to add it to the resulting or residual gas. So that's why this answer is 105. Look at this other question. Which of the reactant was in excess? Of course, from here you can know that the reactant that was in excess is oxygen, because of this 21, 5 cm cube that reacted, leaving behind 16. So oxygen was in excess. So your answer here is oxygen. All right, the last question. This question is a little bit tricky. Just follow the question. All right. This is between hydrogen and oxygen. Okay. 20 cm cube of hydrogen gas has packed with 20 cm cube of oxygen in an endiometer at 373 Kelvin and 1 atmosphere. The resulting mixture is cooled to 298 Kelvin and passed over calcium chloride. The volume of the residual gas is 20 of hydrogen with 20 of oxygen. As usual, half of 20 is 10. 2 times 10, 20. What you have here, since here is 20, because the molar ratio are the same, here will also be 20. Right? So this is gone. 20 minus 10. 10. They said the volume of the residual gas is normally, I said the volume of the residual gas is the volume of the product plus the volume of the reactant that is in excess, or the one that is the unreacted gas, right? Normally you say 20 plus 10 to get your residual gas or the resulting mixture. But look at this question very well. 20 cm cube of hydrogen gas as packed with 20 cm cube of oxygen gas in an endiometer at 373 Kelvin and 1 atmosphere. The resulting mixture, that is the product, right? The resulting mixture is cooled to 298 Kelvin and passed over calcium chloride. That is, they are saying in this gas, after it has reacted, then the gas was passed over, was cooled. When you cool the gas, what will be left will be liquid. You understand? When you cool a gas, when it was the resulting mixture is cooled, it's cooled at this temperature. What will be left will be liquid. And it was also passed over calcium chloride. So the calcium chloride is to remove the liquid component, but your product now will now be liquid. And I said Galussa's law. Liquids do not obey Galussa's law. Since normally this is liquid, supposing this was a gas, I would just say 20 plus this 10 to get the volume of the residual gas. But since from this question, when you read the question, you find out that this product is a liquid, meaning we are not going to use this one in calculating residual gas. Instead, your answer will only be 10 cm cube. Why? Because the product has turned to a liquid. That's why I said this question is a little bit tricky. If you're in a hurry, you just say, okay, the volume of the residual gas is 20 plus 10. No, because from here you can see that the mixture was cooled and passed over calcium chloride. When you cool it, it turns to liquid. All the vapor component was now removed using this drying agent. So since this one is a liquid, we will not add this to this 10. Instead, your answer will only be 10 cm cube. So your answer is 10 cm cube. So that's the end of the video. This is just for some calculations. This is not odd calculations. You can try your answer on other questions under Galussa's law of combining volume. So as usual, if you enjoyed the video, you can leave a like and subscribe. Thank you.